All right, so here's another differential equation. We've actually seen differential equations like this as well. And we saw that the solution set looked like it was going to be an exponential function. But now we're actually going to solve it and prove that we get an exponential function when we have a differential equation like this. So, okay, so there's no x terms in this. We just have dy dx is equal to some constant times y. All right. But so the way we're going to separate these variables, we're going to divide both sides by y and multiply both sides by dx. So we end up with 1 over y dy is equal to k dx. Okay? Now we've got the variables separated and we can just integrate both sides. So we get the natural log of y is equal to kx plus c. Don't forget your plus c. All right. And so that's telling us we can raise each side to, we could do essentially e to both of these. Write it like that. Yes. Right. And then what we'll end up with is y is equal to e to the kx plus c. Right. And then we can also write that as just e to the c e to the kx, right? Because if you can see, if I multiply, I'm multiplying two powers, so I add the powers, right? So I add the exponents, sorry. So you can see that. And this e to the c, this thing here is just a constant, right? It's e to some unknown power, so this e to the c is just some other unknown constant. And we can replace it with just a different letter instead of writing e to the c. Now also, e to the c is always positive, but y can be either positive or negative. So if we want to get rid of the absolute value signs over here, what we can do is say y is equal to a e to the kx, where a is some constant that can be either positive or negative. Okay, so that's essentially our solution, is that y is equal to some constant times e to the kx. All right, so let's take a look at this little box down here before we go. So a differential equation is called separable if it can be written in the form dy dx equals some function of x over some function of y, and then we can just integrate both sides. Right, so up here you can see in this example we don't really have, it's not, we can actually write this as being k over 1 over y, right? That's the same thing. So we're even though it doesn't really look like a ratio of two functions, we can actually transform it into a ratio of two functions. And that allows us to solve a system of, differential equation if the variables are separable, so we can get all the x's on one side and all the y's on the other side. All right, so in example 4, the next example is one for you to try. It's very similar, I think, to some of these other ones, but give it a try. You never know if you know it until you do it. So give that one a try, and I'll meet you to go through it in the next video.